Hello, my dear students. Welcome you all to Shri Jayendra Rank Zone classes. I am your mentor and your friend for the subject chemistry, and I will be taking organic chemistry. My dear students, today we are going to start with very important chapter of organic chemistry, class 12, that is alcohols, phenols, and ethers. In this lecture, we will be studying about the classification of alcohols and ethers. We will be discussing about the nomenclature of alcohols and ethers, and we will be discussing about the physical properties. So let us begin with alcohol, phenol, and ethers. So starting with the general properties of alcohols, when hydrogen atom of hydrocarbons is replaced by OH, that is hydroxy group, the substituted compounds are known as what? Alcohols. Alcohols, they have an alkoxy group or araloxy group attached to them, attached to parent hydrocarbon chain. The alcohols, they are classified on the basis of number of OH group attached to the parent hydrocarbon chain. Monohydric alcohol having one OH group, dihydric alcohol having two OH group. In this, glycols are a good example. And the third is polyhydric or trihydric alcohol, more than two OH group. In this, we have example of glycerol. Okay, so glycerol is a trihydric alcohol, ethylene glycol is a dihydric alcohol, and normal ethanols, they are monohydric alcohols. If the carbon attached to the OH group is sp3 hybridized, example 1 degree primary alcohols, 2 degree secondary alcohols, and 3-degree alcohol or tertiary alcohol. Next is allylic alcohols. Here also carbon is sp3 hybridized. In this allylic carbon, this is the allylic carbon, this is the vinylic carbon, this is the allylic carbon, which is 1 degree. Here the allylic carbon is 2 degree. And here the allylic carbon is 3 degree. Okay. Then come benzylic alcohols, in which the OH group is attached to the side chain, which is further attached to the benzene nucleus. This is primary. This is benzylic. This is benzyl or secondary. And here comes the tertiary or benzo. Okay. Now, the compounds containing sp2 carbon attached to the OH group. Arylic alcohols. Vinylic alcohols. Phenols. When we talk about ethers, they are classified as simple ethers or symmetrical ethers. If they contain same alkyl group or aryl group attached to the oxygen atom. Mixed or unsymmetrical ethers, in which the alkyl or the aryl group attached to the oxygen atom are different. Okay. Nomenclature of alcohol simply includes the addition of the prefix, addition of the suffix OH, that is all. Alkanols. Cyclohexanol. Okay. In case of phenols, especially the substituted phenols, The IUPAC name is benzene 1,2 diol, and the common name is catechol. Resorcinol or benzene 1,3 diol. And the last is quinol or hydroquinone. Benzene 1,4 diol. Okay. In case of ethers, anisole or alkoxy alkane, methoxybenzene. Methoxyethane or we can write methyl ethyl ether. Okay. Here you have to follow the alphabetical order, and that is why the correct alphabetical form is ethyl methyl ether. Now, when we talk about the structure, bond angle versus ether. In case of methanol, the bond angle is slightly less than the tetrahedral angle, that is 109 degree. In case of phenol, as we know, the carbon is sp2 hybridized, so there will be a partial double bond character over here, and that is why the bond angle is greater. But in case of ether, the plus I effect is more pronounced. That is why the lone pair on the oxygen atoms, they are not available for the repulsion, and that is why their bond angle is high. Okay. Here we can see, because of high repulsive interaction between alkyl groups. The bond angle is more. So this is about the structure, IUPAC nomenclature and the classification. Then physical properties. When we discuss about the physical properties, and physical properties, the most important is, as you know, alcohols, they can make hydrogen bonding. We are going to discuss about their boiling points. Boiling point is directly proportional to the number of carbon atoms in the length of the carbon chain, as it will increase the van der Waals forces. Boiling point of alcohols is inversely proportional to branching, as branching decreases the surface area and decrease in the van der Waals forces. As you know, the OH group of alcohols is involved in hydrogen bonding, and that is the reason they are soluble in water. Okay. Boiling point of alcohols is more than boiling point of ethers of comparable molecular mass. If we want to compare the boiling points of hydrocarbons, alcohols, and ethers, the boiling point of alcohols of the comparable molecular mass is greater than ether, which in turn is greater than alkanes. As you know, alkanes, hydrocarbons, they have only van der Waals forces, while ether, they have van der Waals plus hydrogen bonding. A tendency to make hydrogen bonding is less because of steric hindrance due to steric repulsion. While in case of alcohols, H bonding is more dominant. As far as solubility is concerned, alcohols and phenols are soluble in water due to their ability to make hydrogen bonding. Solubility decreases on increasing the length of carbon chain. Lower alcohols, they are more soluble in comparison to higher alcohols. So this is about the solubility. So my dear students, the properties of some important alcoholic compounds we'll discuss in the next turn. Till then, bye bye, take care, stay safe, stay healthy.